Oi lads, it's Danny here today, bringing you a lovely video on the derivative of secant x. Why is that equal to secant x tan of x? Let me prove it to you now. But before we begin, please drop a like and subscribe and let's get right into it then. So to prove this, we're going to apply the limit definition, same as before, using this formula right over here. We're going to replace f of x with secant of x. So we're going to take the derivative of secant of x using the limit definition. Once you rewrite it, it's going to resemble something that looks like this. Notice secant could be rewritten as 1 over cos. So that's the trig identity we're going to apply right away. So once you do that, you are going to have two fractions that look like this. Once you get to this point right here, we're going to try to get a common base. So we're going to multiply on the right hand side cos x plus h, and in the numerator cos x plus h, and on the left hand side we're going to do cos x and cos x in the numerator. So here we're basically trying to get a common denominator. So this is the calculation right over here. And once you do that, you will obtain a fraction that looks like this. Notice the division divided by h, you can turn it into a multiplication by doing 1 divided by h. Right, so once you get to this point on right over here, what you are going to have to do is we're going to expand this term right here, cos of x plus h, and we're going to expand it using the trig additive definition basically. So we're going to basically rewrite it as cos of x cos of h minus sine of x sine of h, this section right over here. Once you reach this point, what you lot are going to notice, we're going to distribute the negative, so this here is going to become a positive. So once you reach over here, what you lot are going to notice is we're going to split this fraction into two. Basically we're going to make one, right now we got one fraction, but we're going to split it into two fractions. You'll see why in a moment why we have to do this. So therefore we're going to write it in two different limits, as you can see on your screen. Once that is done, we are basically going to factor out a cos of x on this side. And when you factor out cos of x, what you lot are going to notice is that we got a 1 minus cos of h divided by h. And we can basically move this out of the limit over here and just do a multiplication with the same limit, but with 1 minus cos of h divided by h. And we have the same thing over here, sine of h divided by h. We're going to do the same thing over here. These are very interesting limits, whereas, you know, they're going to be equal to 0 according to the squeeze theorem. So you can prove this via geometry and the squeeze theorem. And likewise, you can do this with sine of h divided by h. So this here is going to be equal to 1. So over here, we've got a term multiplied by 0. So this is going to go straight to 0. And we're really going to be left with is this limit right over here, because this limit over here is equal to 1. So taking the limit of this is very straightforward. You're going to replace the 0 where the h is, and you are going to have sine of x divided by cos of x, cos of x times cos of x. We're going to basically split this into two fractions. 1 divided by cos of x using your trig identities. That's going to give you secant of x, and sine of x divided by cos of x will give you tan of x. And that's basically it. That's your answer, and this is how you prove the derivative of secant of x. I hope you all enjoyed this video. If this video has helped you all, please drop a like and subscribe, and I'll see you all later.